So in yesterday class, we discussed about something about the routing, right? I hope now you guys have better understanding how, what is the use of ARP, what is the use of ICMP like this, right? Everyone. Okay.
Yes.
Hi, Nabil. How are you, brother? Okay. How is going on? All good? Okay. So Nabil, actually, we are going to start routing. Clear? So first of all, what do you mean by routing? Anyone? Routing means what? Routing is made up of one word that is called route, or you can say route. Route means anyone. Just route the packet. It means just forward the packet to the correct destination. That is called routing. For example, everyone please focus very carefully. If I have a router, PC1, PC2, PC1 send the packet will reach on the router, and router route this packet from this network to this network. That is called routing. Yes or no? Everyone. Yes? That is called routing. Everyone. Yes, na? That is called routing. And you guys know one thing. Let's suppose these are the interface. 1, 2, 3, 4. 4 interface of a router. It means all the 4 interface of a router will be in the same network or different network. Different network?
Different networks.
Yes? Okay. Before this, first of all, you guys need to remember how we can assign the IP address. Okay, na? For example, this is the router number 1, router number 2, router number 3. There is one switch. There is one more switch. There is one more switch. And here PCs are connected. If anyone asks you, just tell me how we can assign the IP address. So just tell me one thing. This is called LAN network. Yes or no? Everyone. Yes?
Yes.
This is
Yes.
called LAN network. Okay. And tell me one thing. This one. This is called in one network, na? Yes or no? This is in the different network. This will be in the different network. And this will be in the different network. Yes or no? Yes? Everyone.
Yes.
And this will be in the different network and this will be in the different network. You guys know or not? Yes, na? Agree?
Yes.
Because
Yes.
every interface of a router will be in the different network. So it means, for example, if here I am running the 10th network, I can't run here 10th. Here will be a different network like 20. Here we will run 30. Here we will run 40. Here we will run 50 like this. Yes or no? Yes, na everyone. I hope you guys understand. Clear?
Yes, sir.
Now the next thing is, this is the router. This is the PC number 1. This is the PC number 2. For every PC, there will be a unique IP address and unique MAC address. Let's suppose 10.1 and the MAC address is, let's suppose 0A. IP address is, let's suppose 20.1 and MAC address is 0B. Here, let's suppose IP address is 10.10 and this interface MAC address is, let's suppose 0C. Here 20.20 and MAC address is 0D. Clear? Everyone, I hope it's clear to all of you.
Yes.
On PC number 1, I write a command ping 20.1. On PC number 1, I write a command ping 20.1. What will happen? Anyone?
Not reachable. Will not ping. It is on different.
What will happen?
We need to
First,
route.
you write the ping command, immediately PC number 1 will generate one packet. The name of that packet is the ICMP packet, right? Because ping is a utility. What is ping? Ping is a utility. And ping use which protocol, guys? ICMP protocol. So that's the reason PC number 1 immediately raised the which packet? ICMP packet. In ICMP packet, what is the source IP address? That is 10.1, right? Now, what is the destination IP address, guys? Destination IP address will be 20.1 because you already write ping 20.1. Now, source MAC. Source MAC will be, guys, 0A and destination MAC. Now, what PC number 1 will do? PC number 1 will look up its which table is ARP table. You know, na, every PC maintain one table that is called ARP table, right? In ARP table, PC maintain the IP address and what is the MAC address of that IP address, right? Now, everyone, yes or no? Yes, but PC number 1 look up its ARP table and PC number 1 will find no, for this IP address 20.1 I do not have MAC address in my ARP table. Yes or no, everyone? Yes, PC number 1 didn't find MAC address for which IP? 20.1 because this is our destination, na everyone? Yes, so destination MAC is missing. So it means what PC number 1 will do? PC number 1 will hold this packet. Anyone who do not understand till now? Anyone? It's clear? Okay. Now, to solve this problem, it means PC number 1 don't know what is the MAC address. What is the MAC address for which IP? 20.1. So to solve this problem, PC number 1 will generate which packet, guys? ARP packet. That is called address resolution protocol, right? In ARP packet, what will be the source IP address? Source IP address will be, guys, 10.1. What will be the destination IP address? That is 20.1. Now, after that, who can tell me?
Source MAC.
MAC
Source
address.
MAC.
Source MAC and
Zero.
destination.
0.
Okay. You are telling source IP, destination IP. Done. Then source MAC. Right now, I am asking to all of you. Then I will tell you. So destination, sorry, that is the source MAC and destination MAC. Source MAC will be, guys, 0A.
0A.
And destination MAC will be, destination MAC will be
Broadcast MAC.
Broadcast MAC.
broadcast.
FF.
Okay, but in ARP packet, you guys will get 0000. I saw you yesterday class
Unknown.
because
Unknown.
for
Unknown.
PC number 1, destination MAC is unknown, right? Na everyone? Destination MAC
Yes.
is unknown, right? But at Ethernet header at layer number 2, you guys will get the destination MAC what? FFF.
FF.
Understand? Everyone. It means this is the broadcast. Are you guys confirm this? All the details which I am written here, is it correct? Everyone. Anyone who is telling this, the address which I write here is not correct? Anyone? Yes, Nabil. You are telling something? No? Okay. Guys, one more thing. Before this, I just clear you one more thing. The destination will be default. Default means? Tell me the address. Default gateway, you are telling. Okay, everyone try to understand. Before this, first of all, we need to understand one thing that is called default gateway. What do you mean by default gateway? Everyone, please focus very carefully. Default gateway is nothing. Default gateway means exit point of your network. Try to understand. Here I assign which IP address, guys? 10.1. Here I assign which IP address? 10.10. It means this one. This area is called in which network? 10th network? Or no? Everyone. Yes?
Yes.
This one is called which network?
20 network.
20 network. Agree? Agree. It means when PC number 1 wants to exit from its network, what is the exit point or what is the door? This is the exit point. Yes or no? Everyone. Yes, nah. When
Yes, sir.
PC number 1 wants to exit from 10th network and PC number 1 wants to, let's suppose, wants to go in the 20 network. So first of all, PC number 1 must need to exit from its network. Yes or no? Yes, na.
Yes.
Let's suppose right now I am here. I am living in my home, and let's suppose I want to go outside. So first of all, I need to exit from my door, na. Yes or no? Everyone.
Yes.
Yes. Similarly, PC number 1 is there, and PC number 1 wants to exit from its 10th network. So definitely, what PC number 1 will do? PC number 1 needs to exit from its network. PC number 1 needs to exit from its network. So what is the exit point? This is the exit point. And what is the IP address for this exit point? That is called 10 dot, and that is called default gateway. Anyone who do not understand default gateway, it's clear? Everyone. Clear na everyone? Default gateway.
Yes, sir.
So default gateway means the exit point of your network. Okay. So anyone have any different answer? The thing which I am written here is the
sorry to
same,
interrupt. Hello.
same, or there will be any change?
Hello, Shivam.
Yes,
Sorry
please.
to interrupt. I think some people are not able to join the class. Can you suggest something there? They are asking.
Sorry,
Like-
we're asking?
In WhatsApp, they are asking. They are not able to join the class.
They are not able to join the class. Why?
I think do you need to exit the class? I think.
Okay, cool. So I hope now everyone understand what do you mean by default gateway. Anyone who do not understand default gateway, it's clear? Everyone understand?
Yes, sir. Yes, sir.
Guys, okay. Now
Yes.
same topology I am drawing here. Okay, so it will help you to understand more better. This is my router, and here I am taking two PC number 1 and PC number 2. This is the same topology we have right now.
Yes.
I told you every PC has which address, guys? IP address and MAC address, right?
MAC
Everyone.
address.
And how we assign the IP address, I hope you guys already know. This is the MAC address. I am just copy this MAC address here. Clear? So this is the MAC address. Now, how can we assign the IP address? 10.0.0.1. Clear? Now, after that, you are getting one more thing that is called default gateway. And I hope now everyone understand what do you mean by default gateway, right? Everyone.
Yes.
Default
Yes.
gateway. PC number one, if PC number one wants to communicate with this PC and this PC belongs to 10th network, this PC belongs to 20 network. So if this PC wants to communicate with this, it means this PC must need to exit from 10th to 20. Then this PC is able to communicate. Yes or no? Everyone. Yes. Similarly, if PC number 3 wants to communicate with PC number 1, PC number 2 must need to exit their network. Yes or no? Yes, na everyone?
Yes.
Yes.
Yes, sir.
So it means we need to specify the default gateway. Otherwise, how PC number 1 will know what is the exit point? Getting my point? Everyone understand? So on PC number 1, I am going to assign 10.1 and here we are going to assign 10.10. Here we are going to assign guys 20.10 and here we are going to assign 20.1. Anyone who do not understand? This is clear? Okay.
Yes, sir.
Yes.
Come on PC number 2, desktop. So this is the MAC address for PC number 2. Now, on PC number 1, we already assigned IP address 10.0.0.1, subnet mask we already assigned. Now we are going to assign what? Default gateway. That is 10.0.0.10. That's all. Clear? Anyone? Done? Come on, PC number 2. Same thing. IP. What is the IP address? 20.0.0.1. Subnet mask by default. And what is the default gateway? 20.10. 20.10. Clear now, everyone? So I assign the IP address as well as the default gateway. Now, after this, we need to assign the IP address on the router. How we can assign the IP address on the router? I hope everyone now know. What is the interface?
Configuration interface.
Gig 0 by 0.
Gig 0 by 0 interface.
What is the IP address? 10.0.255.0.0.0 and then you have to write what? No shutdown command. Because I told you every interface of a router is by default shutdown state, right? Interface gig 0 by 1 IP address. What is 20.10? 20.0.0.10 255.0.0.0 and then no shutdown command. Clear everyone? I hope it's clear to all of you. So IP interface brief. See what I assign on gig 0 by 0 I assign 10.10 and on gig 0 by 1 I assign 20.10. This is clear everyone? Are you tell me? Understand now?
Sir, one doubt, sir.
Okay.
Yes, sir. Understand.
Please.
Sir, one doubt, sir.
Yes, please.
Sir, actually, default gateway same network address you have to provided, but with 10 PCs are connected to them. Then 10 PCs are connected to default gateway. How it decide the default gateway, sir? Actually, network and how many PCs they are connected to them router.
See, you are telling, let's suppose this is the router and you are telling, let's suppose 10 PCs are connected like this, right?
Yes, sir. Yes, sir.
But tell me one thing, if you connect this PC here with this interface and this one PC here with this interface, it means this will be in the different network and this will be in the different network, na?
They all will be the different network.
Yes, sir.
All will be in the different network.
Yes, sir.
For example, if you connect one PC number 1, if you connect PC number 2, and if you connect PC number 3, what is the IP address you assign here? Let's suppose you assign the 10.1, and here what you assign? You need to assign 10.10. Clear? Let's suppose on PC number 2, you can't assign the 10.2 or 10.3 like this. No, you need to assign the different network ID. Let's suppose I assign here 20.1 and this one is 20.10. Here I assign 30.1 and here I assign 30.10. So for PC number 1, what is the default gateway? 10.10. For PC number 2, what is the default gateway? 20.10. And for this one, 30.10. This is clear?
Okay. Yes, sir. Yes, sir.
Now, you are asking, sir, you have a, let's suppose if you have a more than 10 PCs, but see, you need to ask this question to me, sir, this is the router, but in real scenarios, we are not doing like this because on a router, we have a very limited interface. On a router, we have a very limited interface. That's the reason we have a concept of switch. So by the help of switch, what we can do, we can connect multiple devices in a network. Getting my point? Everyone understand now? So what we can
Yes,
do,
sir.
for example, this is the switch, and on this switch, there will be a multiple port, right? Around how many? 48. Okay. So for example, these are the PCs you connect. Let's suppose here you connect 40 PCs. And what is the IP address? For one PC, you assign 10.1, 10.2, 10.3, you can assign here because this is called LAN network. This is called LAN network. Getting my point? And let's suppose here you assign 10.100. This is the IP address. So it means for every PC which is connected here, for every PC, what is the default gateway? 10.100. Understand? I hope now you understand. Clear now?
Yes, sir. Yes, sir.
Yes, understand.
That the answer or dynamically it will be-
Sorry, your voice is not clear.
is that default gateway is user defined or like dynamically it will assign itself?
Basically, yes. In real environment, it will dynamically assign. It will dynamically assign. Basically, if you are working in the company, definitely there will be a one server team also. You know, server team. Yes. Who is managing the Active Directory in your company, DHCP, let's suppose DNS server, these type of things. So basically, this is the responsibility of server team to assign the IP address, as well as the default gateway, each and everything dynamically. Clear now? Basically, there is a role of DHCP. So by the help of DHCP, your device will get these things automatically. You do not need to assign each and everything manually. No, never. Clear?
Okay.
So, sir, the
Yes.
job role of the server engineer and the network engineer is completely
Yes,
different.
completely different. So that's the reason you see in the CCNA and CCNP syllabus, we are not reading the DHCP and DNS. This type of thing is not there. Why? Because this is not our business. Clear?
So we are not gonna manage the server.
No, we are not going to manage the server. See, basically what I can
That they are going to manage the network, only the
as a
LAN
network
network.
engineer, see, as a network engineer, what you need to manage, try to understand. For example, I'm just drawing the one topology here. Okay, this is you can say this is one of my client topology. I'm telling you. For example, I'm one client is there. Let's suppose XYZ is my client, and who is sitting, let's suppose tower 7, 4th floor. Getting my point, everyone? So there are multiple switches are there. Basically, on a switch, max to max, 48 ports you can connect. Yes or no? Yes, na? But
Yes.
for example, on this floor, there are more than 200 users. So it means with the help of one switch, you can't connect each and every users. This is not possible, right? Everyone. So you need more switches, right? So when you divide 200 by 48, what will be the answer? Who can tell me? Around
Right.
Four.
5, 6.
Four. Five.
5 switches.
So let's suppose there are 6 switches. Okay, na? So what you will do? See, your connection will happen like this. this is the access layer. Okay, now after the access layer, there will be the distribution layer. In distribution layer, we can manage, you can say our core device. There will be a DR, designated router, you can say. Getting my point? So we have a DR. On DR, we have a two DR, DR1 and DR2. One DR will fail, then we have a other DR. Getting my point? And after this, what is happening? And this DR is now again connected with the firewall. Getting my point? And after that, these two DR is again connected with the another router that is called PE router. And let's suppose in my company there are multiple branches, Philippines, US, Canada, like this. So for internal communication, we are using the MPLS. And for let's suppose if there are a client and this client needs to communicate with the internet also, then there will be a ISP, and we have a two ISP, ISP1 and ISP2. If one ISP goes down, then we have a ISP number 2. So these type of thing. But for example, these are the PC. These are the PC. How these PC will get the IP address, subnet mask, like this. So for this, you know, there is a one more zone that is called DMZ zone. If anyone know DMZ zone, right? Basically, in this zone, what is this? There are multiple servers are there. Fine. And what, as a network engineer, what is your responsibility? Your responsibility is to make it connected with the DR. That's all. Basically, there is a one core switch, and that core switch is connected with the DR. So as a network engineer, you have to check only this one. You need to provide the connectivity from DR to that switch. That's all. Nothing more. And for internal task, how DHCP configure, what is the DHCP utilization, how how many IP address assigned, everything. This is the responsibility of server. This is the not responsibility of network. Clear? Understand? Everyone?
Yes.
So, sir, the access layer is the under of the server team.
No. Why? This is on access layer. There is a switch, and there are end users are connected. Let's suppose if this end user are not getting the internet, to whom they will reach? They will reach definitely to the network engineer, not to the server. Getting my point?
Yes.
Firstly, you guys will get the concern of, you guys will get the ticket that my internet is not working. Getting my point? So when you troubleshoot it, then you guys will find, let's suppose the high IP utilization. Maybe you guys will get this this PC is not getting the IP address. Then you guys will reach out to the server. You see, this device is not getting the IP address. So let's suppose VLAN number 100, all the user is in VLAN number 100 is not getting the IP address. Then server team will check what is the utilization of IP address. Getting my point? That is the task of then server team. But as a network engineer, you need to just provide the connectivity to the DMZ zone. Then all the server will provide the IP address, subnet mask, default gateway, each and everything dynamically. Clear? Understand?
Okay, sir.
Yes.
You ask the question and you move me in the different zone.
Sir, access layer and distribution layer, distribution switches then connected them directly, na sir?
See, that is DR1, DR2, that is called distribution layer. There will be a access layer. In access layer, switch are generally connected in the stack. Don't ask me what is stack. If you want in a detailed way, you guys can watch the video. We already uploaded on the channel. So basically all the switches are in the stack. Stack means, just understand, when you stack all the switch, it means now we are considering a single switch. Physically, there are 6 switch, but we are considering how many switch? 1 switch. So you can take the console of 1 switch and you can configure on each and every switch on a one go. Getting my point? Everyone understand? Are tell me? Clear now?
Yes,
sir.
sir.
So
Yes, sir.
I think the switches only one. Okay.
there will be a, you can say na, in networking language, this is called uplink. What? Uplink. Getting my point? But when I teach you, I will tell you trunk. But in a networking language, that is called uplink. Getting my point? And this uplink is connected with the DR like this. Like this. It means when uplink will goes down, you have another. So what will happen? This access link, this access layer switches. Let's suppose these are the end user. So end user will send the traffic. Traffic will reach on the access layer. What access layer will do? Access layer just forward all the traffic towards the DR. Why? Which link? This link. And this is called trunk link. Clear? Everyone. I hope you guys understand. Arey, tell me. Clear na? And now this is the responsibility of DR. Either DR will forward this towards the ISP or either DR will forward towards the PE, that is called MPLS. Or if the communication is internal, then it will forward towards the MPLS, and if that is for the internet, it will forward towards the ISP. Are you understand everyone? Yes or no? Clear na?
Yes, sir. Yes, sir.
So don't think access layer is not connected with the DR. If access layer is not connected with the DR, then how can you reach the internet? This is not possible, right? Access layer is only responsible for connecting all the users. That's all, nothing else. And all the routing facilities on each and everything, who will provide? DR will provide you. Access will never provide you. Access layer switch is always layer 2 switch. Please remember this one. Access layer switch is always L2 switch. And on DR, you guys will get the L3 switch. Because on DR level, what we are doing? We are doing the routing also. Getting my point? Basically, in many company, you guys will see companies nowadays purchasing the L3 switch, not router. Because nowadays, we have a concept of L3 switch. On L3 switch, you can configure the routing. Then why company purchase the dedicated device router? No, why company will invest? Getting my point, everyone? Understand? So in maximum company, you guys do not see the router because nowadays maximum company are using what? L3 switch. Are you getting my point, everyone? Yes or no? Clear? Can we start then? Okay.
So, sir, the facility of the router, the L3 switch same.
Maximum facility you guys will get in the L3 switch compared to the router. Cool?
Okay, sir. Yes, yes.
Okay. So PC number 1 will generate the ARV packet. Okay. Now actually we are saying there. We configure the, I think, IP address. So IP interface brief. Yes, we configure the IP address. Yes, na everyone. Show
Yes.
interface gig 0 by 0. When I see gig 0 by 0, what is the packet tracer? There are very limited thing. Zero by 1. 3602 3601. Okay, that is important for 0 by 0. What I copy? 3601. 3601 is for 0 by 0. And for 0 by 1, acha, okay. 0 by 3602. Got it. It means this is the MAC address for this interface and this is the MAC address for this interface. Clear na everyone? Are tell me. Clear?
Yes.
Now come here in simulation mode. Add it. We want only ARP and ICMP. On PC number 1, command prompt, I write here ping. What is 20.0.0.1 na? Yes or no? Everyone? Yes?
Yes.
Yes, sir.
Yes.
I write this. How many packets are there? 2 packets are there. I am opening this one. What is this? This is the ARP. No, first of all, need to open the ICMP. This is the ICMP packet, right? Everyone, see, this is the ICMP packet. This is the IP header, but this packet is not completely encapsulated. Why? Because see na, layer number 2 is not there. Layer number two means source MAC, destination MAC. These are the
MAC
things
address.
missing. Yes, MAC address are missing. It means this PC number 1 don't know what is the destination device MAC address. Yes or no? Everyone tell me. Yes, na?
Yes. Yes.
Yes.
Yes. PC number 1 don't know. So that's the reason you can say this packet is not completely encapsulated. So that's the reason this packet will be hold here. Getting my point, everyone? Now, open this packet. What is the source IP address? 10.1. What is the destination IP address? 20.1. Clear? Everyone, yes or no? Yes, na?
Yes.
See, in ICMP
Yes.
packet, what is the source IP address I written here? 10.1.
10.1.
What is the destination IP address here written here? 20.1. Right? Everyone, tell me. Clear, na? Okay.
Yes.
This packet is hold because destination MAC addresses is missing. Now come here. This is the which packet, guys? ARP packet. Yes or no? In ARP packet, what is the source IP address?
PC IP address.
10.1. It means this is the PC number 1 IP address.
What?
Yes or no? This is the this PC IP address. But what is the target IP address?
10.20. 20.
No, see na, see
So
very
20.1.
carefully. That
Gateway
is
IP
10.10.
address.
Gateway.
Guys. That is
10.10.
10.10.
Default
That
gateway.
is, yes. Now I am telling you, I told you, I think in yesterday class also, ARP packet never cross its own network. Yes or no?
Yes.
Yes, sir. Yes,
It
sir.
means when PC number 1 will generate the ARP packet, the same ARP packet never go in this network. And when PC number 2 will generate, this ARP packet will never go in this network. Right now, everyone? Understand? Yes or
Yes,
no?
sir.
Yes.
Yes, sir. Yes.
So that's the reason in ARP packet, destination IP address never be 20.1, guys. Never be 20.1. What will be? Default gateway. That is
10.10.
10.10.
it's 10.10. Anyone who do not understand, it's clear to all of you? Yes.
Yes, sir.
Now, tell me one thing. If destination IP address is here 10.10, it means PC number 1 is sending this ARP packet towards its default gateway. Right or wrong? Right? It means PC number 1 is sending this ARP packet to its default gateway. Yes or no? Yes, na? Everyone?
Yes.
Yes. Now, what is the use of ARP? To find out the MAC address. Yes, na everyone. But this ARP packet is not going to here na in this network. Are tell me yes or no? Yes, na.
Yes.
It means this ARP packet will go to the default gateway and find out the MAC address of its default gateway, not PC number 2. Yes or no? Agree? Yes or no? Everyone.
Yes, sir.
If this packet is not going to this network, then how your ARP packet will find out the MAC address of PC number 2? This is not possible. Your ARP packet is max to max going here. Right, na? Everyone at the default gateway. PC number 1 is sending the ARP packet and this ARP packet is going max to max here. So it means this ARP packet will find out the MAC address of its default gateway, not destination. Are you getting my point? Understand? Yes or no?
Yes.
Yes, sir.
Everyone.
Yes.
Yes, understood.
Come here. Close it. See which packet? This is the I am opening. Inbound means the router receive this packet and outbound means router sending this packet. Understand na everyone? Inbound, outbound. Are you tell me?
Yes.
Guys.
Yes.
Okay. Inbound means router receive this packet. Router receive what is the source IP address? 10.1. What is the target IP address? Are tell me.
10.10.
10.10? Yes or no? Yes. Now, what is the source MAC address?
8705. B705.
B705. And B705 is the PC number 1 MAC address.
PC
Yes
one.
or no? Yes?
Correct.
Okay. Correct. Now, come here. Let me check if we are able to see or not. So, ARP.
Or
What is the IP address of PC number 1? That is the
yeah,
10.1.
B705.
And what router did? Router install MAC address in which table? ARP table. Yes or no? At which interface? Gig 0x0. Can you tell me yes or no? Yes? Everyone.
Yes.
It means when this ARP packet reach on the router perform first thing that is called listening task. After listening, router learn these things in which table? ARP table. Right? Everyone. Can you tell me? Right?
Yes.
After learning, router will process what? Forwarding task. Right now, everyone. In forwarding, what router will do? I am opening the outbound packet. See, in outbound packet, what is the source IP address?
10.10.
10.10. It means this ARP packet reach on the router. What router is doing now? Router is generating the ARP reply. Yes or no? Everyone, this is the ARP request. Right? Everyone. Now router is generating the ARP reply. In ARP reply, what is the source IP address? 10.10. Because router is sending the reply through this interface. Na? Yes or no? Everyone. Yes, na?
Yes.
This router never forward this ARP packet towards here. I already told you these things. Right? So now this router is forwarding this ARP reply towards PC number 1. Right? So what is the source IP address? This interface IP address, that is 10.10. Clear everyone? Yes or no? Yes? Now,
Yes, sir.
now come on. What is the target IP address? 10.10. And what is the target IP address? 10.10. It means target IP address is 10.1. It means PC number 1 is target. Right now, everyone? Because this router is sending the reply towards PC number 1. So target is PC number 1. Clear everyone? Are you tell me yes, no?
Yes, sir.
Now, what is the source MAC address? Please see. 3601. It means this interface MAC address. Yes or no? Everyone?
Yes.
3601. It means source MAC is here. What is 0C? Are yes, na everyone? Yes? Okay. Now, what is the target MAC? B705.
PC1 Mag.
What is the target
PC1
MAC?
MAC
B705. It means this is the PC1 MAC address. Right now, everyone? Yes.
Yes.
This is the PC1 MAC address. So it means destination MAC will be 0A. Are you tell me yes or no? This is the ARP reply and router is sending this ARP reply towards PC number 1. And router, what router do? Router maintain this entry in which table? ARP table. What is the entry for 10.1? What is the IP? 10.1. And what is the MAC address for 10.1? That is 0A. And which interface? Gig 0x0. Because this is 0x0, na? Yes or no? And this is 0x1. Are you clear na everyone? Yes or no? Yes?
Yes.
Yes.
Everyone? Anyone have any doubt? Anyone? No? Very good. This packet reach on PC. What PC will do? Again, PC will perform, guys, listening, learning, and forwarding. Are tell me yes or no? Yes, na? PC also
Yes.
perform listening, learning, and forwarding. Right? So what PC number 1 will do? When this ARP packet will reach on PC number 1, PC number 1 will open and check what is the source IP address. What is the source IP address? 10.10. What is the source IP address? 10.10. And what is the MAC address for 10.10? What is the MAC address? 0.
0C.
And make this entry in which table? ARP table.
Table.
In which table, guys? ARP table. Are you getting my point, everyone? Yes or no? Tell me. Clear?
Yes.
Now,
Yes.
what PC number 1 will do? PC number 1 will initiate the ICMP packet now, which was hold. Why this packet was hold? Because destination MAC was missing. Yes or no? Everyone, tell me. Yes? Are tell me yes or no? Yes, na everyone?
Yes.
Now, see here. This is visible, everyone? Are tell me. Clear?
Yes.
So,
Yes.
packet comes to the router. What router is doing? Router forward this packet towards PC number 1. Open this packet. What PC number 1 is? PC number 1 receive it. It means only there is an inbound packet. Right, na? Everyone. There is only inbound because PC number 1 received this packet. Clear? Now, what PC number 1 will do? PC number C, open this packet now. In ICMP packet, see, now Ethernet header is also visible. See, na? Source MAC and destination MAC is visible there. Yes or no? Everyone, tell me.
Yes.
Are tell me.
Yes, sir.
Yes. It means what PC number 1 is doing, PC number 1 now working on the ICMP packet. In ICMP packet, PC number 1 write the destination MAC address of what? Which MAC address? 0C. What is, guys? 0. See, it means default gateway MAC address. Which MAC address, guys? Default gateway MAC address. Are you getting my point? Everyone, tell me yes or no.
Yes, sir.
Yes? Anyone who do not understand? It's clear to all of you?
Yes. Sir.
Router also one of the MAC address is considered, sir.
Sorry, router.
Also one of the MAC address considered.
Which MAC address?
Actually, PC1 is sent to the MAC address, the IP address. Then also the MAC
P-
address is also assignable.
PC number 1 is sending the ICMP packet, and in this ICMP packet, the MAC address is of this router interface MAC address.
Okay.
Clear? This
Correct,
now
sir.
what PC number 1 will do? PC number 1 now send this ICMP packet which was hold. This was hold na previously. Why? Because destination MAC was missing. But now in this ICMP destination MAC is already filled. Right, everyone? Tell me yes or no. Yes?
Yes, sir.
Okay. See, now PC send. What is this packet? I am opening this packet. This is the ICMP packet. The router receive. Yes or no? Everyone. Yes, na? This is the ICMP packet router receive.
Receive.
But see now what is happening? You are getting here cross. It means router drop this packet. What router is doing, guys? Router drop this
Drop the
packet. Why? Any reason? Everyone.
No routing. is
Any
available.
reason?
Because there are two different networks.
Router.
Because they are two different network. Okay.
So,
They are
only-
crossed to the network. So other
Guys,
network.
tell me one thing. Tell me one thing. See,
Because the
Router-
destination IP address and the MAC address are not matching.
router send this ICMP packet here. Okay. Everyone understand what router will do? Router need to forward this ICMP packet towards PC number 2. Yes or no?
Yes.
Yes, na?
Yes.
When this ICMP packet reach here, what router will do? Router will forward this ICMP packet towards here. Don't think, sir, how router is forwarding this packet from one network to another. Please remember, router cannot forward ARP packet, but router can forward ICMP packet. Please clear it. Clear na? Understand? So this ICMP packet reach on router. What router is doing? Router is now re-edit this ICMP packet. What the re-edit? See here. What is the source IP address? What is
20
the
dot 20, 20
source
dot
IP
20,
address will be? Sure.
20.2.
Mail madam.
What is the source IP address, guys?
The IP
You
address
can
of
tell me.
20.1.
20.1.
This one is 20.1
That
PC2.
is the destination IP.
No, the IP
Source
address,
IP
the
will be
source
10.10.
IP address,
But router
Destination
will
IP
add
will
it,
be
so
the
that's
IP
why
address of the
this
router,
is
then
20
the
dot.
10.1. The IP address of the router, that's the source IP. That should be 20.2.
Okay. See, guys, source IP address will be 10.1. This one. Why you are changing the source IP address? Why you are changing the source IP address? Because this is the ICMP packet. This ICMP packet can easily go from one network to another. Our packet cannot go from one network to another. So in that case, there will be a default gateway MAC address or IP address. Yes or no? But ICMP can go. Source IP address will be 10.1. Destination IP address will be same 20.1. There will be no change. Now tell me what is the source MAC and what is the destination MAC. Who can tell me?
The source MAC will be the MAC address of the router interface.
This interface, right? Because now router number 1 needs to forward this packet through this interface towards the PC number 2. Yes or no? Yes. So source MAC address will be 0D. Yes or no?
Yes.
Right. The destination MAC address will be, first of all, router will check what is the destination IP address. 20.1.
One.
What is the destination IP address? 20.1. Now router look up at which table? Are tell me which table? ARP table. ARP table. But in ARP table, do you guys find 20.1 MAC address? No.
No.
20.1 MAC address is not there. Yes or no? Everyone.
Yes.
20.1 means PC number 2 MAC address is missing. Right? It means you can say this ICMP packet on this router is again incomplete. Incomplete. So what router will do? Either router will hold it or either router will drop it. Understand everyone? Clear? Tell me.
Yes.
Now, what is the responsibility of router? Router responsibility is to find out the MAC address of PC number.
2.
But how? Again, router will generate which packet, guys?
Yeah.
ARP request packet. What router will do? Router will generate the ARP request packet for PC number 2. Yes or no? Everyone, tell me. Yes? Tell me. Clear na? So see, this is the inbound packet. It means router receive it. So there is no change. Now come on outbound. In outbound, what is this? In outbound, see na? Do you guys able to find Ethernet header, source MAC or destination MAC? No. We are not able to find source MAC and destination MAC here. It means this packet is completely not encapsulated. Yes or no? Yes. Tell me. Yes, no, this packet is not completely encapsulated. See, na, come here. When you, I click here, the next hop IP address is not in the ARP table. The ARP process tries to send the ARP request for that IP addresses. It means for which IP address? 20.1. Clear? Everyone, I hope it's clear to all of you. Tell me. Okay. So this router send this packet. Open this packet. See now, what router send? Router send which packet? ARP packet. What router send, guys? Router send ARP packet. In this ARP packet, first of all, what is the source IP address? What is the source IP address? 20.10. What is the source IP address? Router is sending which packet, guys? ARP request. In ARP request, what is the source IP address? Because router is forwarding this packet through this interface. It means source IP will be 20.10. Sorry, 20.20. Sorry, 20.10, I think, right? Na? Yes, 20.10.
Yes.
So this is the source IP address. Now, what is the target IP address? 20.1.
20.1.
Because this router is forwarding towards the PC number 2. So 20.1. Clear? Now, what is the source MAC address? 3602. It means gig 0 by 1 interface MAC address. That is called 3602. Yes, na everyone? Yes or no? That is 0D. This interface MAC address. Right? Are you tell me?
Yes.
Right, na? What is the target MAC address? 0000. It means this router don't know what is the MAC address of this device. Right? So that's the reason target MAC is 000 and at layer number 2 it is broadcast. Are you clear na everyone? Yes or no?
Yes.
Target MAC is 000. It means this router forward this ARP request towards PC number
2.
2. What PC number 2 will do? PC number 2 open this packet and perform the learning task.
Learning.
Learning task, PC number 2 maintain which table? ARP table. Which table, guys? ARP table. In ARP table, PC number 2 check what is the source IP address. Source IP address is 20.10. And what is the MAC address for 20.10? That is
0D.
And make the entry in which table? ARP
ARP table.
table. Now, PC number 2 will generate which packet, guys? ARP
ARP.
reply.
Reply.
PC number 2 will generate the ARP reply. In ARP reply, what will be the source IP address? 20.1.
20.1.
20.1.
What will be the what will be the target IP address? 20.10.
10.
What is the source MAC address? 0.
0B.
What is the target MAC address?
0D.
0D. Because PC number 2 already know na what is the target MAC address for 20. What is the target IP address? Target IP address is 20.10. Now
10.
PC number 2 will check its ARP table and try to find for 20.10 I have IP, I have MAC address or not. But PC number 2 already know what is the MAC address, right? So MAC address will be 0D. And PC number 2 forward this ARP reply packet towards router. Anyone who do not understand, it's clear to all of you? Everyone? Clear?
Yes, sir.
Yes.
This packet
Yes, sir.
comes here on PC number 2. This is the inbound packet. See, what is the source? Source is 20.10. Right na? This one, 20.10. What is the target?
Yes.
20.1. Target MAC is 000. Now PC number 2 is sending the reply. In reply, what is the source IP address? 20.1. What is the
1.
target IP address? 20.10. Right? What is the source MAC address? B097. It means this is the PC number 2 MAC address. Right now, everyone? Tell me. Right? Now,
Yes.
what is the
Yes,
target
sir.
MAC address? 3602. 3602 means this is the MAC address of this interface. Yes or no? Everyone? Tell me.
Yes.
Yes? And this PC maintain one table. What is the name of that table? Tell me. ARPA. See na, this PC also make the entry in which table? ARP table. Understand everyone? Tell me.
Yes, sir.
Here? Anyone who do not understand till now?
Sir, why have you written -A over there?
This is the command on if you want to check the ARP table in the PC, this is the command ARP /A. Okay. This is the command to check the ARP table in the PC. Even on the router, I think I write the same command. When if you see what I write, so ARP. One more command, so IP R. This is also the command. So there are two commands to check the ARP table on the router. But on if you want to check on the Windows device, what is the command? ARP A. Understand everyone? Tell me.
Yes, sir.
Understand? Are you using laptop? Right now,
Yes,
am I
sir.
using
Yes,
laptop?
sir.
I'm using my mobile phone.
This is my laptop CMD. I am writing here ARP A. See, this is the ARP table of my laptop. Understand? Everyone. Clear?
Can I do the same for my laptop too?
Okay. So guys, this is the ARP outbound means this is the ARP reply PC number 2 is sending. Clear na? This packet will reach on router. Clear? Everyone. What router will do? Router listen, learn. What router will do? Router will learn this thing in which table, guys? So ARP table. See na? In ARP table, now router have entry about 20.1. Yes, na everyone. Now router learn this address in which table? ARP table. So when this packet will reach on the router open this packet and find what is the source IP address. Router will find source IP address is 20.1. Make the entry in the ARP table. For 20.1, what is the MAC address? Then router will get 0B. Then router make the entry in which table? Array which table? ARP table. And on which interface? Router is getting on 0/1. Anyone who do not understand? It's clear to all of you? Everyone.
Yes.
Yes, sir.
Yes, sir.
So now router make the entry for 10.1 and 20.1. Router have both entry 10.1 and 20.1. Clear na everyone? Yes or no? Array tell me. Yes? Array
Yes.
tell me. Yes na? Okay. See, I am opening this packet. This is the ICMP packet, right na? First packet was drop. So that's the reason you are getting when you are pinging first time you are getting na 80% successful, 90% successful or 70% successful. Right na? Why? Because at the first time if ARP exchanging is getting time, then your first or one or two packet will drop. Getting my point? So that's the reason you are getting the result 70% successful, 80% successful. When you immediately when you write the second time, 100% the result you are getting. Are tell me yes or no? Yes, na?
Yes.
Okay. Now again, PC number 1 is sending the ICMP packet. In ICMP packet, what is the source IP address? 10.1. What is the destination IP address? 20.1. Are tell me what is the source MAC address? Source MAC address is B705. It means this is the PC number 1 MAC address. What is the destination MAC address? 3601. It means this is the default gateway MAC address. Yes or no? Yes?
Yes.
Are tell me. Yes, na? Are tell me, guys. Yes or no?
Yes, sir.
Yes?
Yes.
Now PC number 1 is sending which packet? ICMP packet. In this ICMP packet, what is the source IP address? 10.1. What is the destination IP address? 20.1. What is the source MAC address? 0A. What is the destination MAC address? Default gateway MAC address. That is 0C.
E.
PC number 1 forward this packet towards router. What router will do? Router will take the forwarding decision. But how? First of all, router will check what is the destination IP address. What is the destination IP address, guys? 20.1. Fine. And router will check its ARP table and find out for 20.1 I have IP address or not. Then router will find yes, for 20.1 I have IP address in my ARP table. See now for 20.1 what is the MAC address? 0B. So what router will do? Router again change the ARP table. Sorry, which message? ICMP packet. In ICMP packet, what is the source IP address? 10.1. Destination IP address same 20.1. What is the source MAC address?
Zero.
Source MAC address will be
0D. Router.
0D. Why I am getting the different answer? Guys, see, the PC send the packet here. Open this packet. inbound packet. Inbound packet, it's clear to all of you. Inbound packet, there is no change. Now come on outbound. What router is doing? What is the source IP address? 10.1. What is the destination IP address? 20.1. Fine. Now check. What is the source address? 3602. Guys, router is forwarding this packet through this interface. Right? So what is the source MAC address? 360.
3602.
What is the destination MAC address? B097. Because this router already know what is the destination IP address. 20.1. Router try to find out its ARP table and try to check its ARP table and try to find for 20.1 I have MAC address or not. Then router will find yes, for 20.1 I have MAC address what? 0B. So destination MAC will be, guys, 0B, and source MAC will be interface MAC address, that is 0D.
3600.
And router will forward this ICMP packet towards PC number 2. What PC number 2 will do? PC number 2 open. PC number 2 open it. See here. See, packet will reach on PC number 2. What PC number 2 will do? Inbound. This is the ICMP. Request packet PC number 2 receive it. What PC number 2 will do? PC number 2 will generate the ICMP reply. In ICMP reply, what is the source IP address? 20.1. What is the destination? 10.1. What is the source? Source means PC number 2 MAC address, that is B907. Right now, everyone see now? B907. And what is the destination? Destination always be default gateway MAC address. Right now, everyone? That is the default gateway MAC address. And what PC number 2 will do? PC number 2 again make the entry in which table? ARP table. But see na, in ARP table, PC maintain always the entry of its default gateway. Its default gateway entry already there, right na? But now PC number 2 again receive the packet. But what PC number 2 will do? PC number 2 just reset the timer. What? Reset the timer. I told you now. Generally, PC maintain the ARP table for how much time? 4 hours. Right na? So what PC number 2 will do? PC number 2 just reset the timer. Clear, everyone? Understand?
Yes.
So this is the ICMP reply packet PC number 2 send. Packet will reach on the router. What router will do? Router will check its routing table. Are you getting my point? Yes or no? Packet will reach on. This packet will reach on router. What router will do? This is the PC number 2 will generate, guys, ICMP reply. In ICMP reply, what is the source? 20.1. Destination 10.1. Source MAC will be 0B. Destination MAC will be 0D. Default gateway MAC address. I told you, na, everyone. This packet will reach on.
पानी की बोतल देना है.
What router will do?
पानी पी ले.
What router will do? Router will check. First of all, router learn the thing in the ARP table. If router already learn, then what router will do? Router will reset the timer. Now router will take the forwarding decision. But how? Router will check what is the destination IP address. What is the destination IP address here? 10.1. What is the destination IP address? 10.1. Router will check 10.1 is connected with which interface? 10.1 is connected with which interface? Then router will find 10.1 is connected with 0 by 0.
0 by 0.
Which interface? 0 by
0 by
0.
0.
Will forward this ICMP reply packet through 0 by 0. And communication will success. Yes, who raised the hand? Please ask.
Yes, concerning the ARP command, I like you said we should input ARP -A. I just did that on my PC now, and I got some information. I got internet address, physical address, and type. So I got some list of IP address and some subnet mask. So can you just explain again what the first two IP address, what they mean when you put the ARP command?
Basically, ARP double C. Basically, you are getting the result because maximum result you are getting here because previous entries is not removed here. So that's the reason you are getting. Okay. But right now, what you need to focus, see, when I write this command, the three things I am getting: internet address, it means this is the IP address; physical address, it means this IP address is associated with this MAC address. It means there is a one device. On that device, this IP address is configured, and the MAC address of that device is this one. And that is called dynamic. Dynamic means everything is happening dynamically. So you need to focus here on this dynamic. You need to avoid this one, static.
Okay.
Clear?
Okay. So I focus on the dynamic. Okay. The static is for the previous. Is it for the previous?
No, static, you do not need to focus. There are basically these static, maybe some static I configured according to the company requirement, and maybe in your laptop, if you are getting, it means that is already by default configured in your Windows. So there is no worries about it. That you can leave it, but you need to focus on the dynamic only. Clear? After every 4 hours, it will change.
Oh.
Clear? I hope everyone now understand very well about the packet flow. Anyone who do not understand? Anyone? It's clear now, everyone?
Yes, sir.
Yes.
Yes, sir.
Okay. So how you guys enjoy the packet flow?
It's
I
nice.
show you
Please,
each and everything
Fantastic.
practically.
I will
I
to
show
get the
you
recommendation.
each and everything practically.
Yes.
Yes.
For the ping, that's the process of ping. What happens when you put the ping command? Ping so ping an interface. That's the process that goes when you want to ping between two different PCs in
See,
in
just a minute. See here, I write the command, guys. One packet is timed out. And I sent how many packet? 4. How many packet I send? 4.
4.
How many
4.
reply I get? 3 reply I get. One is
Last
lost.
one.
Means 25% lost. It means 75% successful. Why one
Yes.
packet is lost? I hope now you guys are able to answer. Because
ARP level.
ARP
ARP.
exchange. Because of the ARP exchange.
Okay,
Clear
because
now?
of the
But when I write the second time, now I will get 100% because now ARP is already exchange, and on my PC as well as on my router ARP table entry is already there. Yes or no? See, tell me, ARP entries is already there on the PC as well as on router. Clear? Everyone.
Yes.
Tell me. Understand?
Yes.
Nabil, do you understand?
Nabil is out.
Okay. Lakshman, Deepak,
Yes, understood, sir.
I hope you guys are also enjoying.
Yes, sir.
Yes.
Yes, sir.
As usual, right?
Hmm.
Okay. So this is the basic thing about the routing. Okay. Now, I'm opening this one. Why? The first thing is about the routing, guys. This is the basic thing you need to understand. I hope this is visible to all of you, right?
Yes.
Yes.
Okay.
Yes.
The first thing is routing protocol code. What do you mean by routing protocol code? See, routing protocol code is nothing. Okay. Routing protocol code means when you check the routing table of a router, I already told you, na, router maintain one table. The name of that table is the routing table. You know, everyone. Router maintain 2 type of table. One table is ARP table. In ARP table, router maintain which information? IP, and IP is mapped with MAC address and interface. Yes, na everyone? Yes or no? Yes.
Yes.
And router maintain one more table that is called which table? Routing table. And on the basis of that routing table, router will take the which decision? Forwarding decision. Understand everyone? Tell me. Clear?
Yes.
Yes.
So when you
Clear.
open the routing table, there you guys will get multiple code. What is? There you guys will get multiple code. And that code is known as what? Routing protocol code. So basically by the help of that code, you guys can easily identify the network, the routes which is present in your routing table. That route belongs to which protocol? For example, let's suppose you are written there C 192.168.1.1. It means what? It means this IP address is directly connected with this router. Maybe you configured on this router. Getting my point, everyone? So C means directly connected. S means static. S means what? Static. It means as a network administrator, you provide the routes. That is called static routes. Are you getting my point, everyone? Yes or no? Understand? Static means what? Static means, understand like this. For example, there are router number 1, router number 2. There is one switch number 1, one switch number 2, and here PC number 1, and here PC number 2. Here you configure 10.1, 20.1, sorry, 10.10, 20.10.
10.
Here you configure 30.1 and 30.2. For example, PC number 1 send the packet, source IP is 10.1 and destination IP is 20.1. Packet will reach here. But tell me one thing, this router don't know. This router don't know where is your 20 network, because on this router only 2 network is connected. Only 10 and 30. So this router only know about 10th network as well as 30 network. This router don't know about the 20 network. Getting my point? And if this router don't know about the 20 network, then how this router will take the forwarding decision? This is not possible. So what router will do? Router will drop your packet here. Getting my point, everyone? Understand? So to make communication possible as a network administrator, so there are two ways. Either you can use the dynamic or either you can use the static. Dynamic means either you can configure any dynamic routing protocol, or static means either you can configure any static routes, or manually you need to tell this router number 1 ki if you receive the packet related to the 20 network, you have to forward this packet towards here. So these are the things you need to tell manually, and this is called static routing. Understand, everyone? I hope this is clear.
Yes.
Understand, everyone? Static route means as a network administrator, manually you need to define the path. When router number 1 will receive the packet, where router number 1 will need to forward that packet. Clear, everyone? Tell me.
Yes.
Understand? So let's suppose on this router, on a router, if you are getting any routes and there is written S, S means what you can understand. This means static. It means as a network administrator, any engineer define this route manually. Getting my point? Everyone understand? Static?
Yes.
Are you telling me?
Yes.
So S means static. R means RIP. RIP is the routing protocol. So if you see any prefix, let's suppose R, and if you see 192.168.1.1, you can see and you can think this route, router learn this route by which protocol? RIP. Getting my point? If you see 10.0.0.1, then what you can think? You can think this network router learn this network by which protocol? OSPF.
Yes.
Getting my point? So these are the code. By the help of these code, you can this will make easy for you. You can easily identify this network or this IP address belongs to Which protocol? Clear, everyone? Understand? Ari, tell me.
Please,
See,
I just want to confirm. You mean by each protocol, we can determine by each IP address, we can determine the protocol with which the router lend the IP address.
sorry, which? See,
I mean,
just see.
by
I'm telling this one. Maybe your doubt will clear. I write the command so IP root. It means this is the command by which you can check the routing table, right? And this is the code we are discussing here. Right now, this is the code we are discussing. So L means local, C means directly connected, S means static, R means rip. Getting my point? B for BCP, E for EIGRP. Getting my point? So these are the code. So by the help of these code, you guys can easily understand this belongs to any protocol, this belongs to local, this belongs to directly connected like this. See now, for example, on this router, I configure 10.10 as well as 20.10. Yes or no, everyone? Yes? So see, what I am getting. C means directly connected. It means 10th network as well as 20 network is directly connected with this router. Agree, everyone? Yes, na?
Yes.
Tell me.
yes,
Yes. So it means see here 10.0.0.8. It means this is what? This is the network ID. This is the network ID. And this network is directly connected on which interface? Gig 0 by 0. And see here 20.0.0.0. It means this network is directly connected on which interface? Gig 0 by 1. L means what? Local. Local means here you guys will get the specific IP address. So Ccna 10.0.0.10. It means this IP address you configured on which interface? Gig 0 by 0. And this IP address you configured on 0 by 1. Clear? I hope this is clear to all of you.
Yes, sir.
Yes.
So this is called code. What is? This is called, guys, code. Understand? Now the next thing is prefix. Prefix means what?
the network portion of the IP address.
Yes. A prefix refers to the network portion of an IP address. It is the representation of an array of IP address that belongs to the specific network. For example, 192.168.1.0. It means this is called what? Network ID. What is called, guys? Network ID. It means 192.168.1.0. 1.0. This is called what? This is called network address. And here that is written /24. /24, this is called prefix length. What is prefix length? And what is /24 means? 24 bit. I told you na, IP address is made up of two things, network part as well as host part, right? So if here is written /24, it means 24 bit is network part. Which part, guys? Network part. And what is the size of IP address? Who can tell me? I told you yesterday class. Total size of IP address is 32 bit. Yes or no? Yes. And 32 bit is divided into network as well as host. 24 bit is called network. So how much bit left? Only 6 bit.
8
Sorry,
bits.
8 bit.
8.
8 bit is called host bit. It's clear to all of you. So if you are getting 192.168.1.0/24, it means that is called prefix, or you can say network address. That is called network address. And 24 means that is called prefix length. Clear, everyone? I hope this is clear to all of you. Prefix
That's
means
24 is
what?
the network
Prefix
bit.
means you can understand like this. Prefix means network ID. That understand like this. See na? When open it, see 10.0.0.0. What is this? This is called a prefix. And what is this? /8 means what? /8 is prefix length. Are you tell me yes or no? Yes, na? On this router, I assign which IP address? See na?
The /32 marks.
So running configuration. What I configure there? See, on gig interface 0x1, what I configured? IP address 20.10 and then I assign what? Subnet mask. Right now, everyone? Yes or no? So 255.0.0.0 means slash how much? 8. And you
8.
know na everyone? I told you these things.
Yes, sir. Yes, sir.
255.0.0.0. It means this is slash 8. 255,
That's 8 bit network bit.
255.0.0. This means slash 16.
16.
And 255.255.255.0. It means that is slash 24.
Class
And this is
24.
called what?
24.
This is called prefix length. Clear, everyone?
So the
Are tell me.
so the prefix length is the network is the number is
Yes,
the
you can
network bit.
understand like this. Prefix length is you can understand prefix length is like a subnet mask. What you define there.
Okay.
Okay. Next is network mask. Guys, I think maximum guys are listening network mask first time. Right? Everyone. Network mask, I think maximum guys are listening first time. But if I am writing subnet mask, how many guys listen this word? I think maximum guys. Right? Are you tell me? Yes, no? So don't worry, network mask is also known as subnet mask. Both are same. Clear na? Everyone. So a network mask or either you can say subnet mask. What is the use of subnet mask? Subnet mask used to determine which portion of an IP address refers to the network part. Alright, tell me yes or no. Yes, na? Everyone. For example, everyone please focus. I am writing 10.0.0.1. After that, I am writing the subnet mask 255.0.0.0. It means this is the IP address and this is called subnet mask. Yes or no? Yes. And in subnet mask, it means this is /8. Yes or no? Yes. 8 means this subnet mask is telling 8-bit is which part? Network part. And rest how much bit? 24-bit is called host. Yes or no? Yes. So that's the reason I am written here. Network subnet mask is telling you in your IP address how much part is network part. So if subnet mask is this one, it means 8-bit is in this IP address, 8-bit is for network and rest 24-bit is for host.
Hosts.
Clear, everyone? So I hope you guys understand network mask. Now, next is next hop. Next hop means the next hop is the IP address of the next router in the path that data must pass through to reach the destination. Think of the next step to the journey. Try to understand this scenario. For example, PC number 1 send this packet. Packet reach on the router. But tell me one thing. This router know what is the 20 network right now? No. This router don't know what is the 20 network. This router only know which network? 10th network and 30 network, because these two network is directly connected. But the thing is how router number 1 will forward. Getting my point? It means you can say this router don't know the next hop. It means this router don't know where I need to forward this packet. Yes or no? Everyone, tell me. Yes, na? That is called next hop. Next hop means what is the next device where I need to forward it. Clear, everyone? So please think like this. When any packet will reach on the router first of all check its routing table. And in routing table, router first of all check, is there any routing protocol is running? So I can take the forwarding decision. Then router will find, no, right now there is no any routing protocol is running. Then router will check if routing protocol is not running. So do I have any next hop to forward this packet? Getting my point, everyone? If router will find the next hop, then router will forward this packet towards the next router. And if router will not find the next hop, router will drop this packet here. Clear, everyone? Tell me. Understand? That is the
Yes.
meaning of next hop. Next hop means where I need to forward this packet next. That is the meaning of next hop. Clear? And there are multiple ways by which you can provide the next hop to the router. Either you can provide statically, either you can provide dynamically. Let's suppose if you are running any routing protocol, it means dynamically you provide the next hop to the router. If you are not running any dynamic protocol, it means you can provide the next hop statically. That is called static route. Getting my point, everyone? Understand? So that is the meaning of next hop. Anyone who do not understand next hop? Clear? Or tell me.
Yes.
If a router doesn't know the final destination directly, it forward the data to the another router, and that is called next hop. It means for this router, who is the next hop? This one, na? Yes or no? Are tell me, yes, na? Guys.
Yes.
Yes.
Yes, sir.
If this PC wants to communicate with this PC, packet will reach on the router. And what is the next hop for this router? This router must need to
R2.
forward this packet towards router number 2. It means for router number 1, who is the next hop? Router number 2. And for router number 2, who is the next hop? Router number 1. Clear, everyone? Tell me. Understand?
Yes, sir.
So that is called, guys, next hop.